Hello, this is Valerie Shirley. Welcome to my demonstration video. Today, I will be demonstrating the independent sample t-test. So let's get started. All right, the independent sample t-test is used to compare the mean scores of two different groups. The question that we've been given is there a significant difference in the mean sleepiness scores for males versus females? We will be using the sleep study survey data. The independent variables are the male and female participants. The dependent variable is the mean sleepiness scores. So first, we need to check for assumptions. So there are 5 assumptions. The first one is the dependent variable measured at an interval or ratio level on a continuous scale? And yes, the answer is yes. Is the sample chosen randomly? And we are assuming yes. Question number 3 is the sample independent of observations? So are there separate observations? The answer there is yes as well. And is the distribution normal? And I just didn't know. So I went ahead and made the histogram. Of course, I just went to analyze, descriptive to statistics, frequencies, and from there in the charts, I made the histogram, and I did the sleepy and associated sensations data. And as you can see, it all does fit nicely under our bell curve. So yes, the distribution is normal. So now we're moving on to assumption number 5, the homogeneity of variances. The variance of the outcome variable should be equal in each group. So we don't know this yet. We need to get a little more information before we'll know the answer to this assumption. So we need to move forward. All right, so in SPSS, using our data, again, we're going to go to analyze. This time we're going to compare means, and we're going to pick the independent samples t-test. And from here, a box pops up, and into our test variables, we're going to put the sleep and associated sensations data. And then in the grouping variables, we're going to put sex, male and female. And so I'm going to go ahead and right click on that. And in my variable information, we can see that 0 is female and 1 is male. So there we go. So I've got all my information, and then I would press OK. But I've already done that. So I'm going to pull my output data back up, and let's go ahead and check out the information that we have received. Okay. All right. In the group statistics, we can see that we have 107 male participants and 144 female participants. And we can also, in the independent samples test, here we're able to check Levine's test for equality of variances. And this is part of that 5th assumption that we needed to check for. And so we are going to look in this SIG column, and the number we see there is 0.476. If the SIG number is greater than 0.05, then we can assume that the variances are equal, and we can see the top row of the second table for equal variances assumed. So right here, equal variances assumed. And so we've checked our 5th assumption, and we can move on. Next, we're going to look over the differences in the two groups. In the sig two-tailed column, we read 0.002 right here. And if this number is less than 0.05, there is a significant difference in the mean scores. If the number is greater than 0.05, there's not a significant difference in the mean scores. So 0.002 is less than 0.05. There is a significant difference in the mean score. And so our question again was, is there a significant difference in the mean sleepiness score for males versus females? And the answer is going to be yes. Because of the significance in the difference between the two means, that our answer is yes, there is a significant difference. So this is the end of my demonstration of the independent t-test.